Hey, hello, and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, make binary tree from linked list. Okay. So what the problem is saying is that we will be given, let's say, a linked list. Okay. And what we want to do is we want to convert this linked list into a complete binary tree. Okay. Now, what is a complete binary tree? A complete binary tree is a binary tree wherein all the levels of the tree are completely filled. That is, you know that each node has two children in the at max two children in the binary tree, right? At max two children in the binary tree. So in complete binary tree, all the levels are completely filled except the last level. So if you see this three, see this three does not have any children. Okay, so this last level is not completely filled, but rest all the levels will be filled. That is, each node will have two children exactly. Okay, except the last level. Okay, so this also can be a complete binary tree because only the last level is not filled. Only this child is missing. Okay, so this is a definition of complete binary tree. Okay, okay. Now, how to solve this problem, right? So we'll be given a linked list head, right? There'll be a head pointer, and we want to convert this into a complete binary tree. So we are going to make use of a queue. Okay, a queue. So what we're going to do, for example, let's say now we're going to take a queue. Okay, and what we'll do, we will first there's this head pointer. Okay, so what we're going to do, we will take this head point, take the node to take this data from the head pointer. We're going to create a tree node out of this. Okay, we'll shift this head over here. Okay, to the next node. Okay, we'll shift this head over here to the next node, and also we'll add this. Okay, we'll also add this tree node, right? This tree node. Okay, this tree node into this queue. Okay, this queue is of tree node. Okay, is of type tree node. Okay, so what we're going to do, so now we have this in the queue. Now what we're going to do, we are going to run a while loop, right? While loop until this head is not equal to null. Okay, until we have processed all the elements in the linked list, we're going to run the while loop. Okay, so now what we're going to do, we're going to take this two again now. Okay, and what we're going to do, we are going to pop this one, which is already here, right? Pop this one out of the queue, and we will take this data, right? This data from this head, right? We'll create a new node, a new tree node. Okay, and we'll assign to the left of the this current node of this current node. This is called current node. Okay, okay, and then we'll also add this node, tree node, into the queue. Okay, also what we're going to do, we are going to proceed ahead. This head, right? This head will move ahead. Okay, it will point to 3. Now again, we'll check if head is not null. It is not going to be null. So what we're going to do, current dot write. This is current, right? This is current dot write. We're going to add this. We are going to create a new node, and add this head data, and add this head data into this. And also we are going to push this into the queue. Okay, this tree node into the queue. Okay, so here we are done like adding the left and right child to this current node. Okay, now we'll come again to the while loop. We'll check if head is also yes, definitely we are going to move head, right? So now we are going to check if head is not null. Yes, it is not null. So what we're going to do, we'll pop this out. Okay, so now this will be the current. We'll pop this out, and we'll create a left tree node. Okay, we'll add this head data. We'll add this head data into 4. Also, we'll add this tree node into the queue. Okay, into the queue. Now we'll check again. Also, yes, definitely we'll move head as well. Okay, we'll move head as well. And now we'll check if head is not null. Yes, it is not null. So we're going to add a right child to the current node. Okay, add this data into this tree node, and also add this tree node into this queue. Okay, so now we'll check. We'll also move the head pointer. Right now it is pointing to the null. Right. So we'll check in the while loop if head is not null. It is null, and so we'll break. And we have this our complete binary tree ready to be returned. Okay. So this is the intuition behind solving the problem. I hope you've got the intuition. Before going to the code, I'll request you to subscribe to my channel because a lot of efforts goes into like solving the problem, creating the video for you. So it will be motivating for me. Okay. So if you subscribe to my channel, thank you so much. So let's move ahead to the code. I'll show the Java code first, followed by C++. Okay. So what we're going to do? So we'll create. So we'll create, or we already have this pointer, right? Node equal to, we'll create a tree node. Okay. And we'll add head dot data to it. Okay. We'll move the head as I told you, right? Head dot next, right? And we'll have a cur pointer, a cur pointer. Okay. Which will assign this node to the cur pointer. Okay. And what we'll do, as I said, we'll have a queue of type tree node, that is, okay. We have a linked list, that is, we'll implement a queue using linked list. Okay. Now what we're going to do, while head is not null, right? While head is not null. Okay. Now what we're going to do, so in this queue also we need to add queue dot current, right? current we are adding, right? Q dot current we are adding. So what is this current again, right? So this was a linked list. For example, 3 and 4 and 5, right? This was a linked list. What we did, we created tree node. We create a tree node and assign this head data into this, right? Also, we push this into the queue, this tree node, right? We push this into the queue. So that's what we are doing. We pushed it. Now what we're going to do, we are going to pop that, pop whatever is the at the front of the queue, right? Right. So it won't be of type node, it will be of type tree. Okay. 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 Now what we're going to do, we are going to create current dot left, right? Current dot left equal to new tree node we are adding, and what we'll do, head dot data. Okay. So now where is the head pointing? Head is pointing here, right? So we have a tree node here, current, right? Which we have popped out, popped out, right? Current. Now what we are doing here is we are creating a left child, right? And we'll assign this data to this node. Okay. And also we'll add this, right? Also we'll add this too. Okay. So that's what we are doing. So current dot left, we have done this. Now we are going to also add into the this current dot left into the queue, right? To the queue. Also we'll move our head pointer head equal to head dot next, right? Okay. So again, we will check here if for the right child, right? So if head is not null, right? We have moved this head pointer to the next, right? So we need to check head dot null. If yeah, it is not null, then what we're going to do? We're going to create a right child. Okay, we're going to create a right child. Let's do this. Let's copy this head dot data. Okay, and also what we're going to do? We're going to move our head pointer, right? And also we'll add current dot right to the queue, right? Current dot right to the queue. So what we did here, so we created, so our head was pointing here, right? Okay, now we create a right child of this current node, right? We create a right child, we assign this data to this, and we also added this 3 into the queue. We also added this 3 into the queue. So q dot added, q dot add, current dot right. Okay, now what we did, so yes, that's it. Now also what we're going to do, yeah, that's it. This is the code. So this will take care. And also what finally we want to return, we'll return this node, which will be the head node, right? Which will be 1, basically. Okay. Let me compile this. Let's see if it is compiling. No, failed. Node current type. Oh, sorry. It should be tree node. Node of type tree. There may be few other errors. I think. Not sure. Okay. Not compiled. Let me also submit. Okay. The test cases seems to pass. Yeah. Yeah, I think the test cases will pass. I'll request you to subscribe to my channel and like the video. Okay. Yeah. Thanks for watching. Let's quickly see the C++ code as well. Okay, so here is the C++ code. So what we're checking here is if head it is null, right? Simply return. Then we are creating the tree node, right? Out of this, we are having this current, right? We are moving the head pointer. We are having this queue. We are having this queue, and we are pushing it in the queue. We are moving this while loop, right? We like head is not null. We are having this while loop, and then what we are doing? We are popping out the front node, right? The front tree node, and we are creating the left child, pushing the left child, moving the head pointer, checking the head pointer if it is null, not null, right? And then creating the right child for the current node. Again, pushing the right child to the queue and moving the head pointer, right? So that's what the problem is. Okay, I hope you've got the solution. Thanks for watching. Please subscribe to my channel and like the video. Have a happy, healthy, and a great day. Thank you so much.